This question is asking us to differentiate this horrendous looking equation there. So you might have differentiated square roots before. If not, I recommend finding a question that requires you to do that. Give it a few practice rounds, but I'll show an example here. If you want to find the gradient, aka differentiate the square root of x, it is kind of tricky when it's in that form. But there's this rule that if you square root anything, let's say the square root of 4, well, that's like saying 4 to the power of 0.5. So chuck it in your calculator. What is the square root of 4? Hopefully you all know that it is equal to 2. All right, now chuck in your calculator 4 to the power of 0.5, or you can even write it as 4 to the power of 1/2. All up to you. So you can do that, and it will give you 2 every time. So we can write this thing now as x to the power of 0.5. That makes life somewhat easier, okay? So let's write it out. But we're not really done here, okay? It's like in a fraction, that's kind of weird. There's this -3 divided by 6. Let's start with the -3 divided by 6 business. We can simplify that. So looking at it, I can see that there's a 3 on the top and a 3 on the bottom. So really I can see that it's like -1 times 3 and 3, oh, apologies, 2 times by 3. That's what I can see that green bit being equivalent to. And we can see that we have one number on the top and one number on the bottom, and we can just cross it out because that is like saying -1/2 times by 3 divided by 3. Now, what is 3 divided by 3? Well, that's 1. Okay, what is, just an example, 2 times by 1? I'd say it would be equal to 2. What is 14 times by 1? Well, that's just equal to 14. What is y times by 1? Well, that's just equal to y. So in this case, we can say that all of that is just going to be -1/2 because all of that is equal to 1. And I guess 1, when it comes to multiplication and division, is like the same thing as 0. When you're adding 0 to anything, it's just equal to that thing, right? So 1 and 0 are good numbers for us when it comes to solving things. So we can say all of this is equal to 1/2. And likewise, oh, it's not really equal, is it? Let me get my nomenclature right. So now we're here. We've simplified it if we need to. And now we've got this pesky x to the power of 0.5. And in the previous questions, you've seen how we can bring that up to the top by using some indices laws and shenanigans there. So if we've got, 1 divided by 4, that's like saying 4 to the -1, and that is 0.25. So you can check it on your calculator if you don't believe me. So in this case, we can say that 1/2, -1/2, times by x to the -0.5 is equivalent to each other. So now this is the step where we actually have to differentiate. So we're up to this step. We need to differentiate 1/2 x minus 0.5. If you want to get funky, you can move the coefficient out the front, and in your head, just differentiate all of this. That's up to you. But what I can say is that it's at -1/2 times by -1/2, okay, because we're multiplying this top bit down. And then the x stays the same, and it's 0.5 minus 1. So simplifying this, when it comes to timesing stuff, right, that time symbol is like 2 arrows. So we can say that it becomes -1 times by -1, 2 times by 2. And that's really like saying 1 divided by 4. Now you can probably leave it here. If you want to get all fancy and funky, you can move it down to the bottom and simplify it as so, but I don't think there's a real need to do that. Yeah, it's not really needed in this question. That just makes it almost more complicated, doesn't it? But yeah, I guess this one at the top in green is your final answer. As I've been saying in the last couple of videos, it's really important that you write down your answer before clicking on the show solutions and the video. Because like English, you might have heard that saying, look, cover, right, check. You've got to write your answer. That makes it go into your head so much faster, and you have to do less work in the long run to memorizing the course. So go ahead, give it another shot. Otherwise, keep going on to the next question if you found this really easy.